Good afternoon, good evening, good morning to wherever you are in the world. Welcome to this week's edition of YFTT, Yugabyte Tech Talks for Engineers by Engineers. This is episode 127. My name is Alan Caldera. I'm a distinguished engineer here at Yugabyte. I've been with the company now 6 years, joining as its original sales engineer back in 2018. I'm joined today by Devansh Saxena from our software engineering group. He has been with us nearly a year now and works on a number of critical projects for us, PG Partman, Connection Manager, and our upcoming migration to PG 15. So Devansh, why don't you take it away and teach us a little bit about PG Partman today?
Hi, Len. Hi, everyone. Thanks for the introduction. So, as you introduced, I have been with Yugabyte for around past 1 year as a part of core database team in India, and yeah, I'm very excited to talk about today's topic of YFTT, which is uh, partition management with PG Partman extension. So, let me then share. Okay. Uh, I think the slides are visible, right?
Almost. Yep, there we go. Go ahead.
Yeah. So, okay, so let's go to the content that we will discuss. So, first we will discuss what table partitioning is all about in YugabyteDB and its use case and benefits that we get from partitioning a table. Then we will discuss when the PG Partman extension comes into the play and what extra functionalities it provide on top of the native support of table partitioning that YugabyteDB provides. We will then go through how to get started, meaning how one can register a already partitioned table to PG Partman extension such that the future maintenance of creating new partitions or dropping old partitions can be done via PG Partman extension without any manual intervention or manual application logic on top of that. Then we will describe how the partition management can be completely automated and scheduled in a periodic manner when integrated with another popular Postgres extension called PG Cron. Then finally, we will go through a demo to see how things work in action. Okay, now let's get started. We will discuss basics of table partitioning. So table partitioning is a process of partitioning a large table into smaller and more manageable subtables called child partitions, which holds the subset of data such that it is governed by the partition boundaries set for a particular child partition. So the use case of table partitioning can be various, like a sale. Let's suppose a sales table partitioned by month, and we want to do some queries that target specific months to scan only relevant partitions. Or let's say a table that stores the audit logs, and and we want to archive the old audit logs to to some external schema where all the archived logs are present, so we can directly select the old partitions effectively without any expensive query. So some benefits of what we get from table partitioning are, firstly, we will get a improved query performance. Like, since the child partition tables have well-defined partition range, a select query with a where clause on partition column can take advantage of this via scanning rows of some specific partitions only, instead of scanning a whole complete table in case of, let's say, we have an unpartitioned table. So this can significantly reduce the execution time, specifically in large data sets. And we also get efficient way of managing data, like partitioning simplifies maintenance tasks like archiving old data or deleting old data by operating on individual partitions, like instead of querying like complete unpartitioned table. And the third benefit is tied with the second one only, like where we can parallelly execute queries and data modifications across the partitions, considering like each child partition is responsible for particular set of data, so it can make some parallel queries more effective. As we know that the child partitions are responsible for storing particular set of data for certain boundary. That was about the native partition support of Postgres, which is supported in YugabyteDB also. But there are some limitations that are there with native partition support, like it does not automatically create the partitions as data is inserted. One has to manually create the partitions or write some sort of custom scripts to handle the partition creation. Same is the case with dataset pruning. Like it does not provide inbuilt mechanism for automatically dropping or archiving old partitions. So PG Partman extension helps to efficiently provide functionality around these limitations of native support of Postgres. So coming back to PG Partman, it is a third-party extension, not bundled with the Postgres, which is designed to automate and manage range-based partitioning. So it is particularly support for range-based partitioning. So apart from range-based partitioning, we can also partition the table on list base, like where we provide list of values of the partition column when creating a child partition, or it could also be a hash based partitioning where the child partitions store data rows corresponding to the hash value of a particular column. But PG Partman provides functionality for the range-based partition tables only, and in the range-based partitions also, it supports two types of partition columns. One is time-based partitioning, where the partition column is a date or a timestamp, and the partitions can be created at different granularity, ranging from hourly, daily, monthly to the yearly. And second is a ID based partitioning, where partitions are based on integer sequences like primary key, or let's suppose we have defined a serial ID column. So based on that, there is a serial based partitioning support also there for PG Partman. Most of the use cases are around time based partitioning because it makes sense in the real world scenarios where we have like monotonic time based entries coming.
This
Now
is
let's go.
also how, excuse me, Devansh. This is also how we support basically the concept of while we support TTL or time to live in our Cassandra API. This is most common. This method is commonly used to simulate the appearance of TTL in the YSQL layer. Go ahead.
Yeah, you can say that. Like basically, it provides a simulation of TTL for the older rows.
Yeah.
Okay, so let's go through the benefits of PG Partman. So basically stems from the limitations that we have discussed of the native partitioning. Like first, like PG Partman automates the partition creation and deletion. We can also schedule a partition management via some cron job or using PG Cron extension, and that we will discuss later in the upcoming slides. It also reduces manual intervention by application logic that it might need to always check if a partition is needed to be created for a new data to be inserted. And one more thing, that PG Partman has extra added benefit that it helps in inheriting some of the related objects that are not obtained from parent table using only native partition support. For example, native partitioning supports inheriting a primary key index on partitioned column, but if we have defined a primary key on a non-partitioned column, then the creation of the child partitions won't inherit that index. Apart from that, there is one scenario of publications also. So if we have defined a attached a publication for a table, but the child partitions won't be part of that publication. So there are some of the like Postgres when it introduces the support on native partition in Postgres 10 up till Postgres 15, they have added some. They have incrementally added the dependent objects inheritance to the child partitions. But even if like in case of some gaps, that is handled by the PG Partman while creating the child partitions via PG Partman functions. Okay, so let's discuss some of the basic syntax, and let's see like how Partman functions work. So we will first go through basic workflow of registering a partition table to PG Partman via a function of PG Partman called create parent, which is used to configure partitions inside the partition maintenance schema. So first we will load the PG Partman extension via the create extension command. And let's say then we have created a normal partition table named as orders, that is partitioned by range and on the order date column, which is a date style column. So at this point, we just have created a partition table, and PG Partman isn't there yet in the play. So at this point, a number of partitions attached to this partition table will be 0 initially. And if we try to insert some row for this table, we will get an error like it doesn't able to find a child relation in which to enter the row, insert the row. Yeah. Okay, so then we'll call the create parent function to create some of the initial partitions and also configure the future maintenance. The select partment create parent command have some of the parameters that we are required to provide. So first is p parent table. This is like schema qualified name of the partition table for which we want to register partition maintenance. P control, this is same as the partition column on which the partition table was created. And then we provide p type, telling PG Partman that what way should be used to create the partitions. So native, if it type is native, so native is used to tell the Partman extension to use natively partition methods that are built into Postgres 10 or later version. So before Postgres introduced the native partition support at Postgres 10, even before that PG Partman was there. So at that point, PG Partman has an option to create trigger based partition sets using inheritance, but that is also named as the Partman method, but this method is now deprecated in the latest versions of PG Partman. Then the p interval field, this will basically provide the granularity of the partition range. It could vary from a quarter hour to yearly. And then p premake, so this argument tells how many partitions are needed to be created in advance to support the new inserts. Okay, so after the execution of the create parent function, initially there were, like as we discussed, like there were 0 partitions, but after the query execution of create parent, we will have a list of partitions being created. So consider today is month of September, and we have provided a premake value of 5. So what it will do, it will create the one child partition for current month. It will create 5 partitions for the previous months, ranging from April to August, and then for the next 5 months also. And also it will also create a default table. This will so all the rows that doesn't belong to any of the child partitions created will go to default child partition that is created by a PG Partman. So yeah, one more thing apart from creating some child partitions, create parent function will also store all configuration data for partition sets managed by them in part underscore config table. This table is created when the PG Partman extension is loaded via create extension command. So when we call this create parent function, it will create a row in the part underscore config table of PG Partman, and The future maintenance job that we will discuss shortly will refer this table to make the decisions about what new partitions are to be created, or like which old partitions are need to be detached or dropped from the partition set. And any update in this table will reconfigure the future partition maintenance jobs. Okay, so yeah, this was all around basic workflow of PG Partmans. Now let's go to more interesting part where we will discuss partition maintenance with PG Cron. So brief intro on PG Cron. PG Cron is a cron-based scheduler that runs inside database as an extension, which allow to schedule PostgreSQL commands directly from the database. We also had a YFTT on PG Cron some time ago, and how it is integrated with YugabyteDB. So further details on PG Cron are mentioned in that YFTT session. Coming back to Partman, so we have a function called run maintenance, which will first check the part config table that we discussed in previous slide to create and drop the child partitions accordingly. When this function is scheduled to run in a certain period, this could automate the process of creating and dropping partitions. So that part of scheduling this function will be done via PG cron extension. So let's go over the syntax. Likewise, what we have done for Partman, we need to first load the PG cron extension via create extension command. Then let's also configure some retention criteria for dropping the old partitions. So in this update statement, to update the row of part config, I am setting retention to 3 months and retention keep table equal to true. So the retention parameter configures the table to have a maximum retention of a certain period. Like in this example, we are configuring to drop the child partitions that are older than 3 months compared to the current month. So let's say current month is September and we have a child partition that is storing the data for January month. So we are basically telling that since January month is like 3 month more than 3 months older than September, so that child partition would be dropped when we execute this run maintenance function. And second option is retention keep table equal to true. I'm setting it to true. So if it sets to true, it configures that the table will not get deleted but only detached from the partition set. So when we do some query on the top level of partition, we won't be considering the detached child partition, although it would be there present in the schema, but it will be detached from the set. So direct queries on the detached child partition can't be done from the parent level. Now let's schedule the cron job. So I have here schedule the run maintenance function to run in every 10 seconds by the name of run maintenance job. And after scheduling the job, we can see from the cron.job view that the job that we have scheduled is being added in the cron.job view, and it is now it will execute for every 10 seconds. We can also check that the run details of each job run for this particular select partman.run statement, and we can see like in the every 10 seconds this run maintenance function will run in real life use case. It would be around, like, let's say if we want to schedule some job, it will be not around 10 seconds, but like obviously once a day or like once a month, depending about what's the rate that new data is being inserted in the partition table. Okay, so as we have set the retention of 3 months, so what will happen is, like, earlier we have 5 partitions older than the current month. So first 3 older partitions are still there, but the last 2 oldest partitions has been detached from the partition set. So color coded also. So for that, earlier they were five, but now there are only three older partitions that are there. And yeah, now let's go to the demo. I will just share the terminal for that. Oh, is the terminal visible, Alan?
Not yet. There it is.
Might Okay, might be some lag.
Okay,
Yeah,
go ahead.
so I've already created a cluster with or this auto preview flag of enable PG Cron. So what it will do is it will load the PG Cron as a shared loaded library, and after that we will be able to create the PG Cron extension. So let's go to the MySQL shell. Okay, yeah. So let's create the Partman extension. I will create the Partman extension within this Partman schema. And now it has been the extension is being loaded, and now let's create the partition table. This is the same partition table that we discussed on the slides. Now if we see the schema, just after creating the partition, it will as you can see, like number of partitions are 0, and it is defined like the partition range. It is defined partitioned by the range and based upon the order date column that we provided while creating the partition table. Now, as I mentioned, like if we try to insert any row on this table, we will get an error. So I'm trying to insert the row for 17th of September, uh, but we will get the error like no partition of relation orders found for the row. Basically, there is no child partition that adhere to the that is responsible for storing this row. So first we need to create that child partition with the boundary set. Then only then this row will be inserted. So let's start using the apartment. As we discussed, like the create parent function, it will register mm, uh, partition table for for the maintenance, and it also creates some initial level of child partitions. So it has returned true, which means like the this function has uh, succeeded. And now let's check the or schema of public orders. So as you can see, like this is the for the current month, and we have partitions for the older months and five for the newer and one default. And if we check any child partition separately, we will see that it mentions like that this table is a child partition of relation orders, and this is the boundary of the data that it will store. And just to be ensure like some we don't explicitly try to insert some out of bound data, the constant is also being added here for each child partition accordingly. So now if we try to insert the same row that we were trying to insert earlier, we will see now the insert is being done correctly, and we can see the row from both the levels, from the partitioned from the parent level and also from the specific child partition level also. So for that I have to query the correct child partition. Yeah, so the we can see the entry from the both the level, but like in general our use case would be like all the select queries and those things would be done from the parent level only. But we can see the effect of partitioning via just doing a simple query explain of a select statement if where we provided the order date as some value. And if we now see the query plan, we will see like there is only sequential scan being done at the particular child, but a particular child that is responsible for storing the data for this order date. So as I mentioned, like it is the query plan is being pruned, and uh, like execution time will be much less, like if we compare to the unpartitioned table where like it will scan all complete table. Okay, yeah, like as I mentioned, like apart from creating some child partition, it will also the create parent function will also add a entry to the part underscore config table. So these were the same arguments that we provided at time of create parent function. Like if you see a partition interval is 1 month, PMake is 5, control is order date. So these all values are the same that we provided at time of calling create parent function. Yeah.
Devansh, a question from the field here. What release is this actually shipping in? Is this in 2024.1? Is it in 2024.2? Can you please
Yeah,
elucidate
we
on
are
that?
yeah, so we are planning to ship it in 2024.2.
Okay. And for the benefit of the audience, 2024.2 will be our LTS release due out at the end of the year.
So now let's discuss how. Now let's add PG Cron to the fun.
Okay.
So let's create the PG Cron extension now. Yeah, extension has been created, and let's update the some retention parameters. These are the same that we discussed in the slide, that the retention is set to 3 months and we have set the retention keep table as true. So it has actually updated the part config table, and like if we again check the part config table, we will see that the retention is now also set, which was earlier unsetted.
Okay.
Yeah.
There's some additional questions from the field, Devansh. So will it only detach the child tables, or will it actually delete the child table as well after detachment?
So this completely depends on this retention keep table parameter.
Okay.
So
Okay.
I'm not sure like if it is by default true or false. I
Mhm.
think it's by default. So if it is true, that means that to keep the table, not to completely drop or delete it, just detach from the partition set.
Okay. And then at the time of detachment, will there be any exclusive lock that will actually be visible?
Uh, any log taken, you are saying?
Yeah, any exclusive lock. So if someone is looking in PG locks, will they see will they actually see a lock entry in there while it's being detached?
So in the basic PG Partman that is present in third party, so in every function that we run, uh, there is some advisory log taken, but that is at create parent level. Or yeah, like basically at the we will discuss the maintenance function also. So at the start of the function, there is a criteria of where the application takes a advisory log, but there is still exception from us Yugabyte side, like advisory log as of now is not completely supported in
Hmm.
Yugabyte. So this one of the limitations that we are currently with the this one.
Okay. And then a couple more questions. What's the advantage of keeping the partition detached and not dropped?
Can you repeat? I think there was
What's
some.
the, so yeah, what's the advantage of keeping the partition detached?
So basically, one thing could be like we are not doing. We're not. We are preventing a data loss. We can say, right? Even like if it is detached, like we can. We don't actually have the data lost. We can still query the child partition explicitly, not from the parent table level. But we can query the child partition explicitly, and like in cases also there is one thing like for, let's say I want to actually remove, not delete, but just move the child partition from the my main schema to some other schema.
Okay.
So in that case, we don't need to actually drop, but just detach and then move the table to the new schema. So let's say a particular schema is there for maintaining archival records or something like sort of that.
Okay. And then one final question. We're just a bit over time, but does partition pruning work by default in YugabyteDB like Postgres? I believe the answer is yes. But if you had any further comments.
So this is the clean example of that, right?
Yeah.
We are just doing the sequential scan on a single table now instead of doing searching for all the child partitions. So
Okay.
this is a native support of Postgres, but it is also supported in Yugabyte.
Okay. Awesome. Well, thanks a lot for your for preparing this for us today, Devansh, and thanks to all you for joining us on YFTT. Be back with you next week.